Good morning, students. Now let us move to sixth problem on system of particles and rotational motion. The speed of a wheel increases from 600 rpm to 1200 rpm. rpm means rotation per minute in 20 seconds. How many revolutions does it make in this time period? So we want to calculate number of revolutions that a wheel can perform in the time period of 20 seconds when its rotation per minute increases from 600 rpm to 1200 rpm. So in this problem, the initial frequency of the revolution is given in terms of rotation per minute. It is taken as mu naught, 600 rpm. Final frequency is given, that is 1200 rpm. So we want to know number of revolutions that this wheel can perform in the time period of 20 seconds. Let n be the number of revolutions. So now I want to know what is the initial angular velocity of the wheel and final angular velocity of the wheel. Later we find what is angular acceleration. From that we will calculate what is the total angular displacement of the wheel in the time period of 20 seconds. Later I will find the value of number of revolutions. See, we know that angular velocity is related with the frequency, the angular frequency of course, which is given by omega is equal to 2 pi into nu. Omega is equal to 2 pi nu, where nu is frequency in this case. So from this I can calculate what is initial angular velocity and final angular velocity. So this implies if omega naught is initial angular velocity, then omega naught is equal to 2 pi into nu here, but initial frequency is nu naught. It is given in terms of rpm. I will convert that into rotation per second. So this can be written as 600 into 2 pi divided by 60. So rotation per minute can be converted into rotation per second by dividing that into 60. So then I will get this as it is 20 pi rad per second. Similarly, I will get what is the final angular velocity. Omega is equal to, it is 1200 into 2 pi divided by 60 degrees, which is again double of this initial angular velocity, which comes out to be 40 pi rad per second. So wheel changes its angular speed from 20 pi to 40 pi rad per second in 20 seconds. So I want to know what is the angular acceleration in this case. If alpha is the angular acceleration, then alpha is equal to this change in angular velocity, that is omega minus omega naught divided by t. So omega is 40 pi here minus omega naught is 20 pi divided by 20 is 40 minus 20 is 20 divided by 20 is 1. So we will get pi in this case. So which means alpha angular acceleration of the wheel in this case is pi rad per second square. So we got angular acceleration of the wheel in the time period of 20 seconds. So now I want to know what is the total angular displacement of the wheel in the time period of 20 seconds. let theta be the angular displacement of the wheel, then we know from the basic equation of mechanics can be converted into the angular quantity as theta is equal to omega naught t plus half alpha t square. It is something like x is equal to v naught t plus half a t square, and I can replace that equation in terms of angular quantity as theta, which is the total angular displacement of the wheel. Then theta is equal to omega naught t plus half alpha t square. Or theta is equal to omega naught is 20 pi into 20 plus half into alpha is 5 into 20 square. Time is 20 in this case. So we will get theta as angular displacement theta as it is 600 pi rad. It is the angular displacement, of course, total angular displacement of the wheel in time period of 20 seconds. Now, if n is the number of revolutions, that is, n is the total number of revolutions, then this n is equal to theta divided by 2 pi, angular displacement over 2 pi, theta divided by 2 pi, which is equal to theta is 600 pi divided by 2 pi, pi will get cancelled, so we get it's 300. So therefore, the total number of revolutions that this wheel performed in time period of 20 seconds is 300 revolutions. So we got the number of revolutions that the wheel performed in 20 seconds as 300 revolutions.